Hello YouTube, this is Salam. In this video I show you how I ran 220 volt AC to my shop. This is a full guide video. I will show you how I trench, how I ran the wire, and I will provide a lot of tips and safety tips. I even made my own circuit breaker box for my shop. I hope you enjoy this video. I end up making this axe. I took this flat stock, I grind it over here, bend it, welded it, and sharpened this area, and I welded this piece of EMT, and it worked great. Way easier than the shovel. And I'm going 16-inch from the surface of the dirt. I'm a little bit deeper, about 19 inches. I will finish it and then I will lay the PVC. I will go straight shot to the shop and glue all the PVC, feed the wire through it, and then I will put the 90s. This way I could feed the wire easier. Also, this works a lot better than the shovel because when they pour concrete for the slab, it's kind of sticking out. Before I started this project, I took some measurement and I planned it. What I did, I took measurement from the outer edge of the house or the garage, because this is located in my garage, and I measure it to the center line. And I also took another measurement from outside the house or the other side of this wall where the hour meter is, and I also took a measurement, and what I discovered, the box for the hour meter, it's located in this area, and this side of it, it's center line with the circuit breaker box, and it's located in this area on the other side of this wall. So what I'm going to do, I'm going to remove this cover to see if there is any wire coming into the circuit breaker. So when I do my cut to go through this wall to the outside, I avoid these wires so I don't damage them. Before you do any type of electrical work, make sure to kill the main line. Also, if you are not familiar with electrical work, don't do this type of work. It could be dangerous. Hire a licensed electrician, let them do the work for you. I'm not going to record this part because once I kill the circuit breaker, it's going to get dark, and it's already a little bit dark in here. So I'm not going to record that. But once I'm blend this and I have the hole cut, then I show you what I did. I killed the main breaker and then I remove the cover. I'm using these battery operated lights. There is no wire connection at the bottom of this breaker other than this one. This would feed the AC or condenser unit outside. It has a breaker mounted on this side. So I know this flex or conduit, it has to go this way and go to the side. This over here, I did it myself. I installed 220 outlet under the circuit breaker. So this area over here should be clear. What I'm going to do, I'm going to knock this one out for 1 inch. That's the size of PVC pipe that I'm going to run to the shop. And then I'm going to cut the sheetrock so I be able to see what's behind the sheetrock, and then I will drill it with the hammer drill all the way to the other side of this wall. I'm going to cut about 4 inch by 6 inches or so, and I could batch it later. This will give me plenty of room to do my job. It's a bad idea to use a sawzall or jigsaw. Once again, you may have AC line or something. I know there is nothing behind this one because, like I said, a few years ago, about 12 years ago, when I mounted this outlet, I know there is nothing right here. But if you're doing similar work, make sure to do it, you know, before you dig your trenches. Make sure to use a shovel and go slowly, just in case there is sprinkler line or water line or electrical or phone. And it's a good idea to call before you dig. I did call them before I poured the concrete for my shop, so I know there is nothing in that area. And I could batch this easily. I have some sheetrock mud over here, and I could cut a piece of wood, maybe 3/4 plywood, and put it behind so I could screw to this one and this one, you know, the patch, and then I fill it with sheetrock mud, sand it and paint it, and it will look nice. Yeah, there is nothing here. And I actually could use this piece when I do the patching. If you cut your sheetrock like this, then you could fill it with mud and you put tape and it doesn't crack. It's a good idea to let the mud go first and fill, you know, this V groove. This will make it strong. What I'm probably going to do, I'm going to mount a box, plastic box, on the other side of the wall, and then I will run a flex, that plastic flex or water tight, and I will run a connector for it from here to the wall to the other side, so the wire, you know, will feed, and then I could fill the area between the flex and the wall or insulation with spray foam. That's what I'm going to do. These, they should, yeah. This will knock out easy. And I need to go buy the wires and a few other supplies, you know, the PVC and all that. And now I have an idea on the length and what I need. I have good plan on what to do in the shop because I built it myself, so I know how I'm gonna run with the wire and all that. But over here I wasn't sure. Like I said, I did this outlet long time ago, so I want to make sure before I buy material to buy the right stuff. I bought all the materials I need. I kind of changed my idea because the 1 inch of this type of a flex is very hard to bend. I won't be able to make that small bend, so I bought 3/4 inch, and I did measure it. The size of wire I'm using, I could fit it easy through this 3/4 inch flex. This big box, I'm going to mount it on the outside wall. I will drill over here and use that flex connector to go over here. I already drilled a hole on the wall. And then over here, I will drill for the PVC pipe to go through it. And on this side, I decided to install outlet, 110 outlet. A lot of time when I service the AC, I have to do it at night because I do it after work and I have to run long extension cord. So this will be a good idea to have this next to the AC. And I'm planning to replace the AC anyway. I bought a new one. After I finish with this project, then I will do the AC. And I bought everything else. I bought drill bit, tap cons to mount these boxes, and PVC fitting, coupling, PVC glue, the wire. I bought number 6 wire and all the PVC I need. This over here will go on the shop end. I need it to be smaller and slimmer. You know, the way it runs to the ground to help us when we mow around it. And I'm probably going to run a big size EMT electrical conduit around the PVC to protect it when we use the trimmer. Like I said earlier, I took measurement from inside my garage, from the outside of the house to the center of the circuit breaker, and I measured the same thing over here and I put mark. So I know it's going to clear this. The bottom of the circuit breaker right here, I put this line, and that's from the concrete floor up. So I know this area over here, it's clear. And this box, I just put this fitting to, it will fit right here. And I'm going to use spray foam after I clean this hole and run the flex, and I will spray foam it, and then I will bolt it using those top con, and when the spray foam expand, it will create a good seal to prevent any leak. And I drill the hole going up like this, so it's impossible for water to go up inside the house. And I will spray foam it from inside. I drill this using my big hammer drill. I just started with a few smaller holes, then I use a larger drill bit and a chisel, and then I got this hole big enough for this fitting to fit through it. I also finished trenching, and I have it about 16-inch depth from the surface of the ground. And now I will lay the PVC, glue it, and I will have the long run. I will measure, you know, the 90s going up, but I won't install them. I will feed the wire through it, and I'll have enough wire to go to the circuit breaker and to the shop. And after I have this straight PVC laid down, then I will install the other end. This way it will be easier than try to fight all these 90s. And then after I run that, then we will bury this trench. I bought a property a while back, and the temporary power main switch, it had a tree felled on it, and the previous owner just put a lot of duct tape to protect the main breaker and all these circuit breakers. When I took the property, I replaced the breaker. I actually recorded, but I haven't posted that video yet. I decided to save this part. I thought I could use it as a spare part because the unit I bought, the new breaker, it's exactly like this one. However, I'm going to use it for this project as a breakout box. I'm going to remove the main breaker because it's 200 amp. And I'm going to trim this so it will fit inside this box. And I have to raise it up to be at the same height as the surface or the cover. And I will cut the cover so I could access these switches without removing anything. I'm going to install a 50 amp breaker at my main breaker in my house. These just as circuit breaker to kill the circuits that I'm planning to run. For now, I'm just going to run one circuit for the outlet I'm planning to install outside my shop, but I'll leave the other one if I install outlet inside my shop and when I rewire my lathe and my mill to 220 so I could use these. This way it will be easier to branch out from this box. I'll bring the main line that I ran to it, the 4 wires, and I will connect them here, and then I will branch out of these circuit breakers, and I will install the ground bar and the neutral bar over here, so everything will be easy accessible from inside this box. If you are interested into making similar thing, I have detailed video when I put my generator together and I show how I built the control box for that generator. But let me give you a quick rundown. I started by cutting this part. I lifted the plastic, marked it, and cut it with the grinder. And I'm going to use this plastic to protect the wires so they don't rub on steel. Then I drilled these two holes and I enlarged this slot. I welded this stud right in the center. Then I installed these two studs over here. And I measured it to make sure this part is centered in the box as far as this distance over here. And then I welded these two studs, removed this one, welded them all the way, cleaned it and painted. And I installed these two terminals over here. And I also cut the cover and painted. And this is done. It came out real nice. I also drilled over here and knocked it out to accept this 90, and I will run flex all the way down to the box I'm going to mount on the side of my shop, and the wires will go right through this one to inside this box. And from here I branch to all the outlets that I'm going to run out of this box. I marked the height of the cover, and then I estimate the center of this box where the plug going to go, and I start drilling until I hit the edge of the stud. I know I have a stud here, but I'm not sure where is the exact edge from the inside. So I marked it, and now I fix to cut this so the square box will fit inside. Perfect. Now what I'm going to do, I'm going to drill this so I could use wood screws to shoot it to the stud. And I'm also going to cut another piece of this 1.5 by 1.5, something that fit inside, and I could screw it over here at the edge with some wood screw, and I apply some glue. So this box will be supported from this side and this side. So when I pull the plug, it doesn't break this box. And this is how I ran the flex down to the outlet. I just drill it with a hole saw with a size little bit bigger than the flex. I dropped the flex between the wall, and I drilled this handy box on the sides. It had holes, but these will only line with this part over here, and this is weak. I need to hit the real wood. And I decided to go with metal flex inside the walls, just in case I try to screw something to the wall so it doesn't go through this one. The other flex, the plastic one, I thought it had aluminum. However, it doesn't, it's only plastic. And I'm using a plastic bushing over here to protect the wires. Alright, it is fixing to get dark. I'm gonna go ahead, connect the flex to the box I made inside, and I will run the wire, but I'll show you tomorrow the outlet I'm going to use and all that, and I will show you the rest of this project. We pulled the wire, and I have plenty of wire, and I use spray foam outside on the box, and now I'm ready to spray foam it over here. There should be plenty. The way I ran the PVC and wires as follow. I started from here. I installed this PVC pipe, I didn't glue it. Then I assembled the other connectors. I also didn't glue them. And then I start to glue the pieces that went straight all the way to the other end. And then I assembled the other part that went up, and I didn't glue it either. And then what I did, I removed both ends. I only left the straight pipe, and I was able to feed the wire through it. I didn't have to pull from this end or run fish tape or anything. It went through easy because I'm using 1-inch PVC pipe, and I had to run a 3 number 6 and 1 number 8. And then I assembled these parts, and I glue the box and all that. Then I showed you how I spray foam it from the inside. Then I ran these 10 gauge wires, and they went easy. I still have some room to run, other wire if I need to. However, there is no need. And now I'll show you how this looked like. My son today, before I came from work, he went ahead and covered all this pipe, and it looked real nice. And because we put a plywood over here and we laid the dirt on the concrete, we didn't have to get more dirt. And it's looked real nice. I used spray foam between this box and the wall, and I cleaned the overspray with rag. And as you see, these 10 gauge wires, they went easy. And there's little bit of room left. This will go like this. I didn't have to guard this PVC pipe because I'm planning to put some plastic over here and lay some concrete blocks so the grass doesn't grow. Over here I use silicone because this is wood. I didn't want to put spray foam. I thought maybe it's porous, it will allow some moisture to get inside. So I just used RTV silicone, and I did bury piece of metal conduit to protect this PVC pipe, so when we use the trimmer we don't damage that PVC pipe. Here in the US there is so many type of plugs for 220. The dryer, the welder, each one of them has different plug, RV, etc. I decided to go with one of these two. I even thought about installing 2 different outlets. However, I didn't want to cut 2 holes in the side of my building, so I decided to go with one. Basically, the way they supply power, or the utility company supply power to the house, they have a secondary transformer, and the 2 outside leg, they are phases that 180 degrees from each other. So they have different of potential, and they produce 220 to 240 volt AC. And there is a center tap, it's the neutral. So if you go from hot leg to the neutral, you're gonna read about 110 to 120 volt AC, same with the other side. And they also supply the ground. The welder, this is a welder female outlet. You only need the 2 hot leg and the ground. This over here, it makes more sense if I want to install just one plug, because I could build an adapter to go from this to this. I just eliminate the neutral. I could also build an adapter that has 2 type of outlet. It has 110, which is ground, hot leg, and neutral, and also supply 220, the 2 hot leg and the ground. And this is what I'm planning to do. Also, in case of power failure, I have adapter to connect this to my generator, and I could supply power to the house through this outlet. So I went ahead and supply this outlet with the neutral, the 2 hot leg, and the ground. The power carrying conductors, the 2 hot leg and the neutral, I ran them using 6-gauge wire, because the ampacity for it, it's 55 amp. The ground, I just ran number 8. And this is acceptable by the National Electric Code. I completely finished with everything outside the house, and I put all the covers on. After I ran the wires, I used this multimeter and I ringed the big wires, the 3 6-gauge wire to the 8-gauge wire, and I labeled them. I labeled the 8-gauge wire as green, and I terminated on the ground bar, and the one I labeled with white, I terminated at the neutral bar. The red and the blue, I terminated on this 50 amp new breaker that I added. It's double throat to supply the 2 hot legs, and I added this breaker for the AC service outlet. And now I need to patch this hole. I also checked all these wires, they're not shorted to each other or to the ground. This is a sheetrock mud. It's still in the dry state. I'm adding just a little bit of water to it. Mix it real well. Keep it into this consistency so it doesn't crack. I'm making sure these screws head below the surface. This is a wet rag. That's good. Once it's dry, I will sand it one last time, and then I will put the cover on the main disconnect. I'm planning to paint the garage in the future, so this will be fine for now. This sheetrock repair came up nice. Looks like nothing happened. I'm using the fast drying sheetrock mud, and I have a fan blow air at it. I sanded it, smoothed it up. I installed the breaker box cover. I had to remove these 3 tabs for this breaker and this one, and the main disconnect is on. I would like to provide a few tips and warning about this kind of work. Number 1, don't attempt this kind of work if you are not familiar with electricity, connecting wire, how the circuit breaker works, etc. Just hire an electrician and let them do the work for you. Number 2, under no circumstances you should remove this cover if the main circuit breaker is on. If you turn it off, that doesn't mean there is no power present at this breaker box. For example, this a 200 amp main breaker, if I kill the power, this will kill the power to these 2 legs. All these switches will be dead. However, the utility feed, where it comes to here, it's hot. So be careful. If this is off, that doesn't mean all the power is off. When I replaced this breaker or the circuit breaker at my property, I called the utility company. They came and they disconnect the power from the transformer that feed my property. So everything was dead and I was able to do the job safely. Number 3, I made sure to size everything correctly. The breaker for my shop, it's 50 amp. The type of wire that I ran to my shop, 6 gauge wire that delivers the 2 hot leg and the neutral, it's capable of delivering 65 amp. Under severe circumstances, if it's too hot, then that ampacity will drop to 55 amp. So I'm good. If there is any problem with the wire, or if there is short, or if I plug equipment that damage, this will trip the breaker before I damage the wire. The ground wire that I ran is number 8 gauge wire, and it's capable of delivering 50 amp. However, the ground wire, it's not meant to carry any current. It's just meant for safety. For the service plug for my AC, I ran number 10 gauge wire. It's good up to 30 amp, and the breaker I'm using is a 20 amp. Number 4, after I ran the wires from this end to the other end, I tested them using a multimeter. I made sure they're not reading any connectivity to each other or to the ground, even the ground wire, because it's not connected to anything at that time. So nothing read to ground or to each other. And I know the wire, in good shape. They're not shorted. Also, when you pull the wires, make sure you don't drag them on concrete. Don't allow them to kink. Don't use a knife or anything. Make sure you protect the jackets as much as you can of these wires, so they make it in good shape between this end to the other end. Number 5, I made sure to not create a ground loop. What a ground loop mean, the wire leave this breaker box and then somehow come back to it. I had a 110 circuit I've been using in my shop for a long time. All the metal conduit that I ran inside the wall is grounded, and all the boxes also grounded. The new circuit that I ran a flex in between the wall. It's made of aluminum, and I have it connected to the breaker box and to the metal box for the outlet, and all that grounded. I made sure nothing metal touching each other from the 2 circuits. Also, when I connected the ground wire for this circuit at the breaker box at the other end, I have it not connected here, and I checked it with the multimeter, and it wasn't grounded. Number 6, I also made sure to not connect the ground wire and the neutral at the other end. This is the only spot the ground and the neutral supposed to be connected to each other. Number 7, I made sure to finish my work outside the house first. I went ahead, ran all the wire, connected everything. I have all the covers on, and then I made my connection in this box. Number 8, I also made sure to test the circuit breakers, the outlet, make sure they built right. They new, but that doesn't mean they are built correctly. They may have a manufacturer defect. One time, long time ago, I witnessed an electrician, he installed a main circuit breaker, and when they went to turn it on to test it, nothing was connected at the other end or at the outlet. The circuit breaker blew up. Since then, I've been testing them. For example, this one, I will check it with multimeter, make sure when I turn it on, this will read, this will read. If I turn it off, this will break the connection, and I also make sure nothing is shorted. And I did same thing with all the outlets. And now I'm ready to turn these circuit breakers on and go test everything outside. Yesterday, when we ran the wire, I put tape on the wire and I closed the circuit breaker box, put the cover on and turn the main line so you'll have electricity at the house. And this morning, I turned it off, removed it, and finished my work inside this breaker box. Let us go outside and test everything. Let us test this outlet. I have 120 from one of the hot leg to the neutral. I have 120 to the other one. And I have 240 between the two hot legs. And I should also get 120 to the ground. If you like this video, please like, share, and subscribe. Thank you for watching. Be safe and have a good day.